Hi kids, this is Mrs. Johnson and we are going to review the rock cycle today. Um, we're going to start with just what rocks are made out of because that's what we've been talking about are minerals. And we know that minerals are these crystals that are naturally found in the earth and they're non-living and they make up the earth. They also are pure and what's the last one? Can you think of it? They are all solid. Okay, if they're not solid and they turn liquid, then they're not called minerals anymore. They're called magma. So we have all these minerals in the earth, and they are what make up rocks. So they're really the only thing that makes a rock and a mineral different from each other is that rocks are like mixtures of minerals. And sometimes, since rocks are mineral mixtures, inside the mixture they also get living things stuck in them, and that's how we get fossils. So there are really a couple of things that you just need to know about minerals that we haven't talked about. We know how to differentiate between them by looking at their cleavage and their luster and their hardness and their streak. Okay, and they're really made two different ways. They either crystallization means like form crystals. So they either form crystals by coming out of a volcano or just cooling inside the earth. Okay, so when magma, which is liquid rock material or mineral material, cools off, it makes crystals. Okay, so they are either made from liquid when the liquid cools off, or sometimes minerals can be dissolved in water. And when they're dissolved in water and the water evaporates away, crystals form again because the mineral can't evaporate, just the water can. And so there are all kinds of water all over the world, in the ground and on top of the ground, that have minerals dissolved in them. And when the water evaporates, those minerals are left behind. And this is how like veins of like copper and gold and different kinds of minerals are found in the earth, and we mine them. But the reason why they're found in these things called veins that look kind of like streams that don't have water is because, well, they were once inside of water and then the water went away for some reason or another. Okay? A lot of times seawater, especially like salty seawater, if you have a salty lake or an ocean, that the water is not there anymore, it'll leave behind salt crystals, which are called halite. That's natural salt. Okay, minerals come in two basic types. Okay, if it is made up of mixtures of oxygen and silicon, so compounds that have just oxygen and silicon in them, they're called silicates, and they make up about most of the earth is just made of different combinations of oxygen and silicon. And if they have combinations of other things in them, they're the opposite of that, so they're called non-silicates. Okay, so minerals make up rocks, and if you remember in elementary school, you learned about the rock cycle. And the rock cycle is basically an explanation of how the world is constantly changing. And there's three basic ways rocks are made. And so there's three classifications of rocks. There's igneous, sedimentary, and metamorphic. And they are constantly, through different processes, turning from one type to another type to another type. So like an igneous rock in the earth won't stay an igneous rock because things happen to them. And they turn into other types of rocks as these processes that the earth goes through naturally, like earthquakes and volcanoes and just weathering. When it rains, it beats down on the rocks and little pieces fall off. So all these processes change one rock to another rock to another rock over and over and over. Just like the water cycle is never ending. It just goes round and round and round. So the first type of rock we're going to talk about is igneous. You probably remember from elementary school that igneous rock is just what is made when magma or lava cools off. Okay? And magma, if magma cools off inside the ground, it makes igneous rocks down here. And if it shoots out of a volcano, it's not called magma anymore, it's called lava. And when lava cools off, do you see how the lava, it comes down in like little layers? Like every time the volcano erupts, it gets bigger and bigger and bigger. And every time it erupts, the lava comes down and it cools off, and it can make rocks up here. So igneous rocks can form in the ground or on top of the ground. And if they come out of a volcano and cool up here, they're extrusive. And they're called extrusive because they're made outside. And so they cool really quickly, because if the lava comes out of a volcano, it hits the air, and the air is way cooler than it is inside the earth. And so they cool off really, really quickly. So they look different. Lava rocks look different than igneous rocks that are found inside the earth. If it's intrusive igneous, that means it cooled off and formed into a rock while it was still inside the earth. So sometimes there are places in the earth where it gets cooler. It gets cool enough for the rock to solidify down here, and they look different than extrusive rocks. So we're going to talk about how they look different. So here's a question. What type of igneous rocks have larger mineral crystals? I want you to pause and think about it and think what your answer would be based on what I just told you. If you said intrusive because it cools more slowly, you are right. Because crystals are those things, crystals are like those atoms or those ions have to organize themselves, right? And they have to be able to move around to organize themselves. So they have to be a liquid in order to get themselves into a pattern. So if they cool real quickly, they're not going to make very big crystals, because as soon as that rock is solid, those atoms can't move around anymore. All they can do is vibrate in place. But if they cool off really slowly, then the bigger crystals are made. The biggest crystal ever found that I have read about was a beryl crystal, and it was found in Maine, and it was as big as a football field. Imagine how slowly that magma had to cool in order to make a crystal that big, for real. Okay, take a second, and I want you to look at the samples that the teacher has, whoever your teacher is, and I want you to talk as a class and decide which ones look like they were made inside the earth, and which ones do you think are extrusive and came out of a volcano and were formed outside the earth, based on whether or not you see the crystals. If you see the crystals, then they cooled more slowly and they were intrusive. If you can't see the crystals, then they're extrusive, and they look kind of dull. Also, if you notice, another sign that you have an extrusive igneous rock is if you see holes, because sometimes when lava comes out of a volcano, it's like it erupts and there's gases like sulfuric acid gas, and there's like horrible gases present as well. And so that gas sometimes forms bubbles in the lava as it comes out. And if the lava cools off, that gas is inside of there as bubbles when it cools off, and so it makes holes because that's where the gas was. Okay, I want you to take a second and fill out this chart. This is on the back side of your worksheet. You should have the front side filled out now. On the back side, there is a little chart, and I want you to write down the cooling rate of intrusive and extrusive rock. Intrusive slowly, extrusive quickly. The size of the crystals. The examples. Intrusive igneous rock is like granite and gabbro. Extrusive examples are scoria, pumice, and obsidian. Now, what's cool about pumice is it is the only rock that floats. Because remember I said that some rocks have those holes because of gas pockets? Well, if there are so many holes that it's so light, it can float on water. And so that's how you can tell if you have a piece of pumice from like a piece of scoria or something else. Obsidian is a really cool rock too. Some books I've read consider obsidian a mineral because it is a solid, pure, inorganic, naturally occurring substance. The only exception obsidian has and why it's not always considered a mineral is that it doesn't form crystals. And the reason is just because it cools so fast that those crystals don't even have time to start forming. So it's like really smooth, and it's sometimes called volcanic glass. It can get to where you can I've seen arrowheads made out of it because it's really sharp in places because of that. In your book, there's a picture of an intrusive rock formation. Sometimes, since intrusive rock has bigger crystals, it doesn't weather, like with the rain and the wind and the sun, as quickly as extrusive. And so a lot of times, extrusive rock will get weathered away over a period of time, and then you'll have these huge intrusive rock formations. Because it lasts longer and it's harder. Another thing that will change like landforms is the volcano shapes. If you have a volcano low in silica, remember silicates are those oxygen and silicon minerals. It flows really easily, like spreads quickly, and so you'll have volcanoes with gently sloping sides, like the Hawaiian Islands. There's a lot of low silica. That's why, have you ever seen like black beaches where the sand is like dark? Those are low silica volcanoes. If they're high silica volcanoes, they will make, they're like the big, tall, cone-shaped volcanoes because it doesn't flow very quickly. The lava doesn't. And so you'll have volcanoes with steeper sides. Which is my next question. It says the color of igneous rocks is determined by how much silica in it. Do you think that's true or false? Were you listening? What's the answer, yes or no? The answer is yes. That's why low silica, that's why they have those dark beaches. So most beaches in the world have the lighter sand color. And it's because most of the sand has been weathered away is from rocks that have silicates in them, which are minerals that are light in color, and they're made out of different combinations of oxygen and silicon, which are two elements on the periodic table. They chemically bond together to make a compound. High in silicates, light color, low silicates, dark color. Okay, now, once you have these rocks, okay, that's what the earth is made out of, they start to get buried deeper in the earth. Deeper and deeper and deeper. So if a rock gets buried into the earth, what are some things that can start to happen? Can it melt? Can it turn into sediment? Can it foliate? Or can more mica start to form? The answer is all of them except for turning into sediment. So things that happen as rock gets buried deeper is A, C, and D. The reason why rocks change as they get buried deeper and deeper into the earth is because the farther you go in the earth, there's more heat and there's more things on top of it, so there's more pressure. And heat and pressure take any existing rock, whether it's igneous already or metamorphic or sedimentary, and it changes them. And there's a couple things that you can see because they change. Okay? First off, the chemical reactions start to take place. The chemical bonds, because they're being pressed so hard, those chemical bonds can't stand the pressure and the heat, and so they will break and they will reform and form new minerals, which is a chemical reaction, remember, a chemical change, and they will form new minerals that will make them look a little bit different. There's a couple things that you will see as metamorphic rocks get buried deeper and deeper and deeper. Okay, when the recrystallization occurs, you will start to see it look a little bit different. A lot of times you'll see things, and I call them sparkles, which are actually little flecks of the mica. If you remember, the mineral mica is kind of that bending mineral that kind of looks like plastic, it will start to form. And so you'll see little flecks of it. And then the slower this process is, the bigger those crystals get. And so you can sometimes see big crystals. Sometimes you can see really tiny crystals of that mica forming as it gets deeper and deeper in the earth. Okay? You'll also notice that maybe it'll start to get harder. So like oil shale, which is really like just really thin sediment, like you find like at a place in a river where it's like really slow moving, or a delta of a river. And then as it gets buried deeper, it'll turn into slate, which is, what old-fashioned chalkboards are made out of. There's one in one of the science classrooms here. And then as it gets buried deeper, it will turn into schist, and then it'll turn into gneiss after schist. And eventually it will start to do something called foliate. And foliation is a process where, I don't know why, but all of the light-colored minerals and the dark-colored minerals will start to get together and make layers. And so you'll see little bands of light, dark, light, dark, light, dark. And that's called foliation. So metamorphic rocks are usually classified as either foliated or non-foliated. So I'd like you to look at some of the rock samples that are in the room and see if you can find which ones might be metamorphic based on what I just said. Okay, now that we've looked at metamorphic rock, we can talk about sedimentary rock. Sedimentary rocks are rocks made from sediment. Okay, the main process that makes sediment is weathering. I call it wet DC, the whole process, because it's easy for me to remember the parts. And if you are following along on your notes, we're now on to the second page. On number 14, you can write wet DC, and then we're going to talk about what the W, E, T, D, and C stand for. So weathering, what weathering means is the sun or the rain or the wind is breaking the little pieces off of the rocks. Like little pieces, chunks of the rock are coming apart. That's what weathering is. Erosion is the rain or the wind blowing or washing those pieces away. Usually, the rain will wash them away to some sort of stream. Transportation means a stream will take those little pieces of sediment, little pieces of dirt and sediment, tiny rocks, and it will wash them to a bigger stream, maybe a river, maybe a lake. It'll get washed away and washed away and washed away until some point where deposition occurs. Deposition is a deposit. What is a deposit? It's when something gets left somewhere. So a deposition of sediment means eventually the water slows down enough that the thing falls to the bottom of the river or the stream or the lake or whatever it's in, and it will fall to the bottom, and then it will sit there. And then more stuff will get deposited on top of that, and more stuff will get deposited on top of that, and it'll start getting buried. Just like I said, rocks get buried, and the reason why rocks get buried is because stuff gets deposited on top of them. And so, eventually, it'll get buried deep enough to where enough pressure will make them stick together. And once they have cemented together, they turn into a new rock. So basically, a sedimentary rock is just like little bits and pieces of tons of different rocks. Sometimes sedimentary rock, you'll see big chunks of rocks, like conglomerate sedimentary rocks. You can see like big chunks. Sometimes you'll see like pieces of sand, and sandstone is, for example, a sedimentary rock where sand has been stuck together and cemented over time. If oil shale is made from like clay and silt that's been cemented together. So depending on how the water's moving, different types of things get deposited and then cemented together. So different types of rocks are made. Okay. which I'm going to go ahead to, hold on, this. Okay, so there's different types of sedimentary rock. If the water is going, and this is actually a picture out of your book, if the water is moving really fast, like near the shore of a lake or near, like in a river where it's flowing really quickly, the only things that are going to settle to the bottom are great big rocks. And that's where you find those conglomerate rocks underneath places where water at one point, the water maybe isn't even there anymore, but at some point, if you see a conglomerate rock, at some point water was moving pretty quickly and the rock got deposited. Sand gets deposited when the water's moving a little bit slower, and then that's where you find sandstone, and then silt and clay will only settle to the bottom if it's deep or like the water is almost completely still, and then those teeny tiny particles can settle out, and that's where you'll find, underneath that is where you'll find shale. There are also special sedimentary rocks called limestone. Limestone is made from shells. There is a lot of limestone in Missouri. If you have lived in this state very long at all, you have gone outside and you have seen a piece of limestone, because it's just one of those little rocks that you'll find everywhere around here. And it's made from shells. So what happens is water, there's some sort of organisms called, that need shells that are living in water. And then those shells will pile up. I don't know if you've ever been on a beach that's like completely made of shells, because there's so many organisms like that around. But shells that get cemented together, they form limestone. And so if you have a really new limestone, you'll see lots of different shells in it. And then as the limestone gets older, the shells get broken apart, and they remineralize, they dissolve, and they reform, and then so you can't really see the shells as much anymore the older the limestone gets. Which, by the way, means that at some point in time, Missouri must have been covered by an ocean, because there's no other way that this place could be covered in limestone if there weren't tons of sea creatures around here at some point, which I think is kind of cool. This is why there's a lot of caves in Missouri, limestone caves, because limestone gets eroded away and then it leaves these caves. This is why Missouri is also prone to, what do you call those? Sinkholes, yeah, which is a cave that just caves in, that you may or may not have known it was there, and then the ground above it just sinks. There's a lot of fossils found in sedimentary rocks. Fossils are the only kind of rock where you're going to find, or sedimentary rocks are the only kind of rock you're going to find fossils in, because fossils are like pieces of dead things that lived a long time ago. And so metamorphic rocks, they're buried deep in the earth, and the heat and pressure would ruin the fossil even if there was one there. Magma would just completely destroy the organism, so there wouldn't be anything left for an igneous rock. So our entire fossil record are dead things that get buried with the sediment as it's being deposited, and then they eventually get stuck in between the rocks as they're cemented together, and that's where our fossils are. Okay, that is the rock cycle in a nutshell. So all of these types of rocks are made in different ways, and they can turn into each other. Any rock can get buried and change due to heat and pressure. Any rock can get melted eventually, and any rock can weather and then be part of a sedimentary rock. And so the earth is constantly cycling these rocks and changing them and changing their forms. So the minerals will recrystallize, and they'll dissolve, and they'll form bigger crystals and little crystals, and they'll just change from one form to the other as they get moved different places in the earth. All right. Finish your notes and have a good day.